Okay, so we look at another example, but this one is just evaluating the triple integral, where the first one we look at how we integrate the x square dy dx dz. Z is -1 to 1, z 0 to 2, and y is 0 to x. Just for practice in evaluating the triple integral. But in exam, you can't see this particular question. So normally in exam, they will give you the question like this. So you have to find your own order of integration and also your own limit. Just like what we have done on the previous example. This one. Okay. Okay, just for practice. So first we have to integrate with respect to y. So x squared is constant. So x squared y 0 to x dx dz. And this will give us the x cubed dx dz. And then we integrate with respect to x. We will have 1 over 4 x4 x from 0 to 2 dz. And you will get 2 to the power of 4 over 4 minus 0 dz. So 16 over 4 z minus 1 to 1. So 4, 1 plus 1. So you will get 8. Okay. And similarly for the second one, how can we evaluate the ex dx dy dz. Z is 1 to 2, y 0 to z, and x 0 to y. So firstly we have to integrate with respect to x. So ex dx will give you ex, and then x equal to 0, x equal to y, dy dz. Then this will give you, it reduced to double integral. So you have ey minus e0 dy dz. Okay, so from triple it reduced to double integral, where when you simplify, you have ey minus e0 is 1 dy dz, and then integrate with respect to y. So ey will give you ey, and 1 will give you y, and then substitute y equal to 0 to y equal to z dz. So ez minus e0. Oh, sorry, I should do one by one. Ez minus z minus e0 minus 0 dz. So ez minus z minus 1 dz. So z is 1 to 2. So integrate with respect to z. Ez will give you ez, z will give you z squared over 2 minus z 1 to 2. So e2 minus 4 over 2 minus 2 minus e1 minus 1 over 2 minus 1. So e2 minus 4 minus e plus 1 over 2 plus 1. So when you simplify e, you can leave your answer in terms of, okay, so itu minus 2 minus 2 minus 4 minus E1 plus half plus 1. So minus 4 plus 1 plus half minus 3 plus half plus 1 minus 5 over 2. So you can leave your answer in this form. But if they mention that you have to leave your or give your answer in 4 decimal places, meaning that you have to evaluate that. You have to give something value, or you can just leave your answer in this form. Okay. So question 2. You have to sketch the solid, okay, bounded by the graphs provided here. So what is this? This is tetrahedron, right? Bounded by all the coordinate planes. And you have to express. You don't need to solve or evaluate, okay? But just express your triple integral in 6 different ways, okay? Because we know that we have 6 order of integration, so you have to find all the limits for all the 6 for order of integration, but without evaluating. Just leave your answer in terms of triple integral. Okay, so to get that, you have to sketch your solid. Your solid is based on the curve or the surface of x plus 2y plus 3z equal to 6. And we have to go to the basic of sketching of the surface. This is tetrahedron. How can we know this is tetrahedron? You have a straight line. You have a linear equation, and you have the total variable, there are 3, then meaning that you have a tetrahedron. So in order to get the tetrahedron, you have to provide the traces. So the trace at x equal to 0, you will get 2y plus 3z equal to 6, which you will get 3z minus 2y plus 6, and z is negative 2 over 3y plus 2. Okay, so when you sketch on zy plane, zy, you have this one. Z is 2. So when z is equal to 0, so you will have minus 2y plus 6, 2y equal to 6, so y is equal to 3. Okay, and then when y equal to 0, you have x plus 3z equal to 6, 3z equal to minus x plus 6, z equal to negative 1 over 3x plus 2. So your trace on the x-plane, you have this, and you got 2. So when z equal to 0, you have negative x plus 6, x equal to 6. Okay, and then when z equal to 0, you have x plus 2y equal to 6. Okay, and then 2y is minus x plus 6, y is negative 1 over 2x plus 3. So when you sketch, we get this y-x plane. So this is 3. And then when y equal to 0, you have minus x plus 6, so x is equal to 6. So when you join them together, so z, x, y. So on zy plane, 2 to 3. On zx plane, 2 to 6. And on yx plane, 3 to 6. So that is your tetrahedron. The tetrahedron is just the surface here, the flat plane here. But then because of, it is stated that the tetrahedron is bounded by all the coordinate planes. So all the wall and the floor. So it's bounded down here, which is z equal to 0, and it is bounded behind here, which is x equal to 0, and it is bounded side over here, and that is y equal to 0. So you have a solid. closed and bounded surface. So you have to evaluate. So you have to, not you don't need to evaluate because we don't have the integral is unknown, just a f in terms of x, y, z dv, okay, over the solid G. So this is your solid G. So now you have to provide all the 6 triple integral. So how can you provide 6? So you have the solid, which is namely as xy solid. So for xy solid, you have dv is dz, right? Because there is no z here, meaning that your region is on xy plane. So dA xy. So here you can have dz, dx, dy, or you can have dz, dy, dx. And then for xz solid, your dv is you don't see the y, right? So you have to put the dy, dA on xz plane. So this will give you dy, dx, dz, or dy, dz, dx. And if you have yz solid, so your dv is, you start with dx, dA on the yz. So you have dx, dy, dz, or you have dx, dz, dy. So you have to provide all these 1, 2, 3, 4, 5, 6 integrations for this specific order of integration, which means that you have to provide this one, this, and this. Okay, so look at the first one. The first one meaning that your solid is lying on xy plane. So if you want to be your region on xy, then what is your then always I mention you have to draw the small people to help you to determine the correct order and also the correct limit, right? So you have to provide the small people to be in what direction. Should be this one. Okay, I should use so this one. So your feet, the feet of the small people is lying on xy plane. Okay, so for that, so what is the region that we should have? Okay, so based on this one, so now determine the region that you have on xy. So the region that you can see is this, and this. Okay, so on xy plane. So if you look at your trace, should be part of your trace. So where is your trace which is related to the curve on xy plane? Down here, right? This one. So the region down here is this triangle. So meaning that your region is in this one. Okay, if you have xz solid. Okay, so for this, your dv is this is what, dx, sorry, not xz, but xy. Xy solid. So your dv is dz, dA on xy plane. So how can you determine whether you want to have? So this one then to split into dx, dy, or dy, dx. So you have to refer to your region here. Your region here. So you want to be x constant or y constant. So let's say you want to have x constant. So you have to draw the vertical line. So this line is lying between. So now determine your x constant. Your x is 0 to 6. And then y is function. So y depends on this lower bound, y equal to 0. And this upper bound is part of this line. So this line is coming from this equation. So which means that you have this one, right? So you have negative 1 over 2x plus 3. So that is your limit of x and y that you have to substitute here. Okay, so for the first one, your dv, we have dz, and because I'm choosing x constant, so dy dx, x constant. So in terms of the triple integral, we have to solve this, right? Not solve, but rewrite. So for that triple integral, so it's become f x y z, where the order is dz, dy, dx. So the limit of x 0 to 6, right? And then y 0 to negative 1 over 2x plus 3 and z. Okay, so how can you determine the z? So to determine the z, remember from the previous example, you have to look at your solid. Okay, as just now we assume that the small people is standing like this, where the feet of this small people is on xy plane. So now you have to ask yourself, who is covering, who becomes your floor, becomes your floor. So your floor is z equal to 0, because this is z, so z equal to 0. So because of now, you have to obtain the limit of z, right? You have to obtain the limit of z, and then you have to determine the lower bound of z. Just now we mentioned that z, the lower bound, your lower bound is the floor, z equal to 0. And then how about your upper bound? Who is covering you? Who is covering you? So the covering you here is part of the tetrahedron. So you cannot put 2. If you put z equal to 2, you have a flat plane, which is, that is your plane, z equal to 2. But that one is not z equal to 2. Yes, the highest z is 2, but not exactly z equal to 2. 2 is part of the point in the tetrahedron. So z, if you provide me z equal to 2, so it is wrong, because this is not flat plane. This is something, a plane coming from the tetrahedron. So you have to look at the equation of the tetrahedron, but you have to rewrite that to be z equal to. So you have to rearrange. You have 6 minus x minus 2y, and z equal to 6 over 3 minus x over 3 minus 2 over 3y. So you will get 2 minus x over 3 minus 2 over 3y. So that is your upper bound. So here you can see that the surface which is covering you is z equal to 2 minus x over 3 minus 2y over 3. So that is become your upper bound. 2 minus x over 3 minus 2y over 3. So then you can substitute into here. So your lower bound 0, and your upper bound is 2 minus x over 3 minus 2y over 3. So that is only the first one, where you have dz, dy, dx. How about, because just now we mentioned that dz, dy, dx, so we already done dy, dx, right? Dy, dx, so we already done this one. So now we want to obtain the x, dy, where your z is the same here, which means that your region, you have to refer to the same region as here, this one. But now we just change, instead of just now we choose x constant, now we have to choose y constant. So to choose y constant, so now this is your point that you have to focusing on. Okay, so now your the second part, the second number 2, you have the triple integral. So the function is the same, but now you just change the order, dz, dx dy. That is the second one. So now you want you want to be x to be constant. So we can see here the y here is between so now based on this one, y constant, so y is lying between 0 and 3, right? 0, 3. Because should be not just stop here. Okay, so just here. If you look at this one, so the highest y is 3. Okay, so 0 to 3. And then how about x? X should be function. So the smallest x 0 and the highest x is coming from this equation. So we have to rearrange this one. So this one to be x equal to minus 2y plus 6. So you have 6 minus 2y. So now we already obtained the limit of y 0 to 3, the limit of x 0 to 6 minus 2y. Now how about z? Then for z, we have to look at this one. And of course, the z should be the same. So the lower bound of z is 0, and the upper bound of z is part of the tetrahedron. So then for this one, we can use the same lower bound and the upper bound of z, because we have the same region and the same solid. The change is only the dy dx and dx dy. Okay, but the limit of z does not change. So we can use the same. So 0 to 2 minus x over 3 minus 2y over 3. So that is the second one. So we done the second one. Okay, so now we look at the exact solid, which means that now your small people is no longer in this direction. Okay, I have to erase this first. Okay, so the second type of solid, exact solid, which means that the region is lying on exact. So where is exact plane? Z and X. So your region is this one, something, the curve lying on the z-axis. So meaning that this small people is standing like that, where the feet of this small people is on the x plane. Okay, so if you sketch on your paper, then you just rearrange your orientation of your paper, or you just look at directly from this screen as well. Okay, so now so tell me, what can you see on the z-axis plane to be your region? So you can see this triangle again, right? But now on the z-axis plane. So based on your traces, which one to be your region? This one, right? Z-axis plane. Z-axis plane. But we have to erase this one. So this is not part of the line. Just 2 to 6. Okay. So that is our region. So this is your region lying on the x plane. Okay, so now we do the same process. Okay, so based on your trace, so you have to refer to this. This becomes your region when you are standing like that. You are standing like that. So your region is lying on the x plane, where you can see here. Okay, so it's based on the line of x plus 3z equal to 6. Okay, so so again, so exact solid. So your dv in general, because you cannot see y, so you have to put y the first and dA. So your a, which part of the region lying on exact plane. So you have dy dx dz or dy dz dx, which means that z constant or x is constant. So in this case, you have to option dy dx dz or dy dz dx. Okay, let's say the third one is this one. So we have z constant. So when we have z constant, So you have a horizontal line. Okay, we have a horizontal line. So from the horizontal line, you can see that the z is lying between 0 and 2. Z constant. And then how about your x? So that is the lower bound of x, and this is the upper bound of x. So the lower bound clearly seen, it is 0, and the upper bound is coming from the line here. But you have to have x equal to. So x equal to 6 minus 3 z. 6 minus 3 z. So then we can see that to solve this integral, this triple integral, so your dv is dy, dx, dz. Z is 0 to, okay, and x is 0 to 6 minus 3 z. How about limit of y? So to obtain the limit of y here, you have to look at your region, your solid again. So now we want to get the limit of y. So this is your feet. Who is becomes your floor when you're standing like this? So you can see that that is y equal to 0. And who is covering you? So the cover, your cover is part of the tetrahedron again. Now what is the equation of tetrahedron? We use the similar equation here, but now you have to rearrange and make sure that your you just have the y equal to. So you have to rearrange. You have to rearrange your tetrahedron equation. So the given tetrahedron equation is x plus 2y. Plus 3z equal to 6. So now you have y. So 6 minus x minus 3z. So y equal to 3 minus x over 2 minus 3 over 2 z. Okay, so then you can see that the limit of y just now from the solid, your lower bound is the floor, y equal to 0, and your upper bound is 3 minus x over 2 minus 3z over 2. Then you can replace here 0 to 3 minus x over 2 minus 3z over 2. That is the limit of y. Okay, so now we go to the number 4. So for number 4, the limit, the triple integral now becomes fxyz. So dy does not change, we only change dz, dx. So limit of y is still the same because we have the similar region and similar solid. So that's why we don't change. We just change the order. Okay, so the limit of y 3 minus x over 2 minus 3z over 2. Okay, now look at your region. We have the similar region here, but now the x is constant. So when x is constant, so we have to provide this vertical line. So x is 0 to 6, and then z is, so that is your point, and that is your upper bound. So z is 0, and then the upper bound here part of this straight line, which is from this equation, but we need z, so we can use this equation. So z equal to 2 minus x over 3. Then you have to substitute here. So 0, 6, 0, 2, 2 minus x over 3. So that is for the third and the fourth order of integration when the region is on z-axis plane. Okay. Now we go to the last two. The last two is coming from a YZ solid, which means that the region is lying on YZ plane. YZ solid mean your region is on ZY plane. So now you are not standing like this anymore. I have to erase that first. Okay, since your region is lying on ZY, so the small people, the feet of the small people should be on ZY. So you are standing in that direction. Okay, your feet is on ZY plane. Okay, so to get that, which is you have YZ solid. So your dA is in your dA there is Y and Z. So this one should be X. So you have dx dy dz or dx dz dy. So based on your solid here, what is the shape that you can see? You can see the region is triangle as well, right? On ZY. Then you have to refer to your trace on ZY. So where is ZY? This one. Okay. So but then your line is just there. Right, 2 and 3. Okay. So this is your region. This is your region on ZY plane. So for that I have to redraw here. So Z, Y, this is 2 and this is 3. So that is your region, where the equation 2y plus 3z equal to 6. Okay. So now let's say we want to have the fifth is this one and this is the 6th. So the fifth you have to have z constant. So when you have the z constant, so you have to provide the horizontal. Okay, so you can see that the z is constant 0 to 2 and the y is function, this one and this one. So y 0 to the line of this one. So you have to rearrange that equation to be just y. So 2y equal to 6 minus 3z. Y equal to 3 minus 3 over 2, 6. So 3 minus 3 over 2, z. So that is the limit of z and y. Okay. So for the number 5, our triple integral becomes f x y z. So our dv is dx dy dz. Limit of z is 0 to 2. Limit of y is 0 to 3 minus 3 over 2z. And how about the limit of x? To get the limit of x, you have to look at your solid here. Okay, so x. Who is your lower bound? Your lower bound is x equal to, this is x, so this is x equal to 0. And your upper bound is part of the tetrahedron. So what is the equation of tetrahedron? You have x plus 2y plus 3z equal to 6. So when we rearrange this, so you just need x, right? Okay, so you have 6 minus 2y minus 3z. Then you have to put that equation. Okay, so this one. So your equation is part of this. You have 6 minus 2y minus 3z. So that is becomes your boundary of your x. So 0 to 6 minus 2y minus 3z. Okay. So for number 6, we just change to be dz dy. So the limit of x does not change, dz dy. So the limit of x does not change, still the same, 0 to 6 minus 2y minus 3z. Now we have the y constant. Y constant, which means now you have to have the vertical line. So y constant, so y is lying between 0 to 3. And then z, so the lower bound of z is this, and the upper bound is this. So z equal to 0, and you have to modify this one. 3z equal to 6 minus 2y. Z equal to 2 minus 2 over 3y. Right? So 2 minus 2 over 3y. For this, when y is constant. So when you substitute, y is 0 to 3, and then z is 0 to 2 minus 2 over 3y. So now we already obtained all the 6 triple integral for different order of integration.